Yeah, thanks everybody for being here, and thanks to our remote panelists as well. So this panel is going to explore the synergies and bridging the gaps between AutoML in academia and industry. And we are very excited to have 5 wonderful panelists, and we can start with introductions for everybody, a couple minutes introduction for everyone. So how about we start with Nick?
Yeah, can everyone hear me just fine? Awesome. So yeah, super happy to be here for the panel. So I'm Nick Erickson. I'm lead developer and primary author of AutoGLON, which is an open source automated machine learning framework by within Amazon. Yeah, excited to talk about the topics here.
Mm-hmm. Hi. Yeah, you can applause if you want to. Hey, I'm Thomas. I just recently, maybe a few years ago, finished my PhD or did my PhD in Frank's lab in collaboration with Bosch. And I worked on neural architecture search, and in particular multi-objective neural architecture search, and also a bit of meta learning. And right now I'm still with Bosch, and right now I'm working more on this a bit more applied side, so checking what kind of new trends are there in academia, and which of these methods are actually helpful in practice, and which of these methods can you really bring into tools so that they are useful for people.
Hello. Yeah, I was introduced before, but I guess for the audience on Zoom, I'm Professor Ioannis Tsamardinos at the Computer Science Department of University of Crete, and also CSO and co-founder of the JAT-Bio company. And I've been working on AutoML and feature selection and the like for a few years.
All right. Okay, now let's move to the online. Also, we're trying to resolve the issue about having video for the panelists on stage. So, Adam, would you like to introduce yourself?
Yeah, sure. Oh, okay, cool. We can see the panelists. You guys can hear me okay, yes?
Sorry?
Okay, nice.
Yeah.
Yeah, you can hear me okay, right?
Yeah.
Okay. So, hi, everybody. So I host a podcast called the AutoML Podcast. I interview many of the people in the room here and folks on the panel. Nick was just on it. We had an excellent time. I got my start in ML after I built a company that was using machine learning to help Democrats with their fundraising. This is after Trump won. And a few years after doing that, for a few years, I realized we had helped them raise about $100 million. And it instantly dawned on me that I should be in the business of trying to promote machine learning to many more people. And so slowly I got into AutoML that way. And I started a company that was trying to build AutoML for folks who are not data scientists, but are software developers. And I did that for a few years. That's also when I started the podcast. We since closed down that startup. This was last December. And I'm now managing a network of about 20,000 machine learning engineers who gather together in about 30 different countries for in-person community events. And I'm also working on my next startup.
All right, thank you. And Bindu, would you like to introduce yourself?
Okay. Yeah, hey, my name is, hello everyone. Thanks for having me on the panel, Colin. So my name is Bindu Reddy. I'm the CEO, co-founder of Abacus AI. Abacus is an AI-assisted data science and AI and ML platform. We've been around for about 4 years or so. We've done some foundational research in AutoML. Actually, Colin is from Abacus, so very proud to say that. One of our alumnus. Our basic theory and vision is that AI, not humans, are going to build applied AI systems. I'm proud to say that we're probably one of the companies which are on the forefront of that revolution. We've got now several Fortune 500 companies using AutoML as well as the generative AI stuff that we're developing in production. And our thesis is basically, and actually we're also happy to use AutoGluon, so glad to have a fellow AutoGluon person in.
Oh, I think you muted yourself.
Oh, can you guys hear me? Or did you hear any of what I said?
It was just the last 5 seconds.
Okay, got it. Anyway, okay, sorry about that. Anyway, long story short, CEO, co-founder at Abacus AI. Good to meet you. And we apply a lot of ML in production, AutoML.
All right, great. So we have a great range of panelists here with the spread between academia and industry and a mix of both. So we have the questions on Slido. Actually, or I guess I can read them out. The online panelists can even see them. And everybody in the audience, please feel free to continue adding questions. So I think I'll start with the most popular question, which has to deal with benchmarks, which I think is a very interesting question. So it says, are existing AutoML benchmarks representative of and suitable for, and methods suitable for challenging problems in industry? Does anybody want to tackle it first?
I guess I'd be happy to take a stab at this. So a lot of the work I do is surrounded by benchmarking. For example, if you have an AutoML system in a current state and someone wants to contribute a new feature to it, or basically a new set of logic that impacts how it trains in general, should you accept that contribution or not? Is it improving the system, right? And this is actually a very nuanced question because oftentimes performance is not just on a single evaluation metric. It's about training time, inference time, how complex is the code base, how easy is it to describe the system to others, debug it, right? All these things are kind of factors here. What I'd say is that for tabular data in the small to medium size category without too much exotic kinds of features and IID, we're in a pretty good spot. So I know that's a lot of caveats, right? So there is something called the AutoML benchmark, which our team spends a fair amount of time on. We try to contribute to that effort to improve it. This is about 104 open data sets that are kind of pretty high quality, I would say. And in this AutoML benchmark, a lot of different AutoML systems have basically contributed working versions of their systems into this benchmark so that they can be evaluated. And I think it's like basically a yearly process in which the authors of the AutoML benchmark will publish a paper showcasing the current state of things and how this is evolving. And so I think that's an absolutely great resource for the community. But with that said, in terms of areas where we aren't IID, we don't have a lot of data about that, right? So when do AutoML systems fall apart? When they make assumptions about the distribution of the data. Also, when it comes to having complex features like dates or text, right, in combination with traditional tabular features, what is the performance of AutoML systems? Do certain AutoML systems even support those things? I think is something where the community improving the amount of data sets and the diversity of data sets available will be one of the absolute highest priority things to improving the overall state of AutoML.
Great. Yeah, anyway, go ahead.
Yeah, I basically have a question. So in the talks today, we heard a lot about it. A lot of the workload is not in the model selection, model optimization step, but even before that, for figuring out how to organize data and how to do feature selection or clean the data and something like this. So are there actually a lot of benchmarks that also kind of have these things where you can't really start off already with a nice data set, but where you actually have to first do all these things in an automated way?
Yeah, if I can comment on this, our team is actually working quite heavily in that direction. With that said, the data sets that have that kind of a property are often not exactly open, so it's hard to publish them. You need to go through certain legal processes, right? There are data sets on sites like Kaggle that are very much in that vein, but you have to also be careful with how you go about using those data sets because they have their own legal guidelines per competition, right? Yeah.
Yeah, I want to. Sorry, go ahead.
Go ahead, Adam.
Oh yeah, I want to add to that. This is very interesting because with my last company, we were not focused on data scientists, right? And so the concept of the data set itself was completely foreign, right? Software developers, they don't know what a data set is, right? And even if we tried to just sort of like explain it to them, they sort of get it, but they can't but think in terms of a database, right? Their world is in a database. They have users, they have items, those have properties, and there's logs and activity and behavior. And how do you actually go about converting that database into something that is machine learning ready as a data set? That is not an obvious transformation, right? And I mean, as Nick was pointing out, it's oftentimes very difficult to do that. You don't have access to the database in the first place, right? Like one of the things you get is just the data set after the fact. And you could have created that data set in lots of different ways. Yeah, like if there was like a more database-oriented AutoML, this is something that I think would be fascinating, right? And so one of the things that my team and I tried to do is kind of like Nick was saying, is there a way to sort of like deconstruct what the database could have been initially, right? And then try to find some automatic ways to. But then again, this is like synthetic data, and it's much more difficult to reason about. But this was certainly the limitation that we had, right? We could have solved everything very well on the existing benchmarks, and it would have gotten us nowhere closer to meeting our users where they were, right? Again, in the database.
So let me echo a little bit of this from a very industry, I think a little bit different perspective from everyone else here, is that what we found was, we had these benchmarks and our research was fantastic. We published a lot. We were, on all the top conferences and stuff. And then to like your point, Adam, the data in the real world is very different. So anything that you apply and works really well on your benchmark doesn't actually translate really easily. So, we've ended up actually trying to create a lot of stuff beyond AutoML, quote unquote. And, it's questionable why it should be beyond, including things like feature selection, data cleaning, et cetera, which needs to be automated. Because from an industry standpoint, we want to automate AI, right? Everybody does. And AutoML, I think, of late has had like this narrow kind of focus on finding the right neural net or finding the right algorithm once you have the data set. So if our benchmarks could actually have some more quote unquote real world data sets, which I understand that there are legal issues, but if the research community made like a concerted effort to get 10 of these, get legal paperwork done, I think it would help the community a lot.
Definitely, yeah. It seems like that's one of the maybe gaps to be bridged is what the data sets look like in industry and in academia. Any final thoughts?
Yeah, let me just say that as we progress, as we make progress with other types of ML, like with complex data, let's say graphs, graph ML, you have feature constructors from graphs, you have feature constructors for images, speech, whatever. And that gives rise to different tabular data, where this type of data coming from featureization, let's say from relational data or whatever, resemble the benchmarks that we have today is completely unknown. So maybe our algorithms work well with the benchmarks we have now, and then when you have feature constructions for relational data, distribution is totally different. Has different characteristics, and they don't work. We don't know. So I think we need to keep continuously updating this type of benchmarks that we have to encompass also constructed data sets, not just only originally the data sets with original quantities measured.
Definitely, yeah. I think it's always a work in progress and making sure all the current academic benchmarks are most suited to industry. Okay, so maybe now we can move on to another question, and actually one that recently became second place in the number of votes I think is a good segue. The question is industry all in on big data and large models, in quotes, or is there a need for small data and specialized solutions? Anybody want to?
I can give it a stab. So I think in industry, right, it very much depends on the problem. For example, not all problems have big data associated with them, right? If you're trying to figure out a problem where you don't have data for it, first you need to get humans to annotate that data. And so then the question becomes, when do you have enough human annotated data to get a good result? Well, the hope is that you would have some system that, generally speaking, will perform well, you know, with irrespective of the amount of data. But of course, as you add more, you get better. And so then it's like, okay, you have a target accuracy or something along those lines that you're trying to get from a business perspective, right? And so I think that saying that, like, going away from small data and like specialized solutions, I don't really think it's that case. I would say specialized solutions, perhaps it is going away a little bit in the sense that really you want to be reusing these very general tools, whether it be large language models or AutoML systems, right? Rather than looking into like Kaggle-style specialized solutions where you spend weeks or months on one particular solution just on the modeling stage, right? Yeah, but I do think that there is a trend towards bigger, more general solutions to a wider variety of problems.
So I think even if you're in this regime where you have big data and big models, for a lot of application, what matters is also that you're very efficient at inference. And so even in this setting, there are many, many applications where at inference time or at like actually deploying the model and using the model, you cannot afford to use these models. So it's still the question is also, how can you actually leverage these models for these types of applications? So maybe you still need to find a like more efficient version of the model or compress the model or so. So I think that in that sense, the topic is not going away, but I also see the trend that, yeah, moving from like one model per use case to one model and then many use cases, but probably still like some adaptation of that one model to the use case. But this adaptation, of course, is like a really nice AutoML question, I know.
My 2 cents here. I actually don't think at all the industry has big data to go all in all big data in a lot of cases. A lot of times people don't have enough data for a lot of their tabular data models, at least, right? If you're thinking about like where we get a lot of like our business from is regression, classification, forecasting, and personalization. If you look at these 4 categories, very few companies have enough data. And if we have enough data, we rejoice. We basically clap and say, hey, we've got enough data to do machine learning. There's a lot of companies which don't have that much, but still machine learning is possible. So I really don't think there is some big trend towards big data or what have you. On the small data thing, regime, I do think that different algorithms work differently. So we've seen kind of like neural networks not work as well compared to trees and such. And there kind of AutoML plays a different role, I would say. So my 2 cents is, yes, we would like to have automated systems, but I don't believe we're fully there. The data scientist is still kind of like useful, even to date. And some of the things that we've used, at least, is we've tried to see if LLMs can help in terms of generating what the type of code that a data scientist can. But yeah, I think small data models and small data systems, I believe, are here to stay because there's lots of companies which just don't have that much big data.
Yeah, maybe I can add to that. I think that it's, when I would talk to people who had never used machine learning, right, but I could just sort of like read through their products that perhaps machine learning could be useful there. The main hesitation they all have is, but we don't have enough data. And no one has an intuition over what enough data means, right? In their minds, it's always like hundreds of thousands, millions, billions. They have no idea, right? So I think there's also an opportunity here. If you can crack the small data regime, well, that's fascinating. One of the most well-attended talks that I organized in New York last year was called Recommendation Systems at a Reasonable Scale. Because almost every recommender system, kind of like algorithm, everything that you're seeing on the blogs and online, they're all just targeting the companies that actually have just like the billions of data points, right? But most companies that need personalization just don't have that. And doing it at a reasonable scale just introduces a whole new set of challenges. And everybody wanted to go and see how to solve those challenges. So it feels to me like there's even more interest in the non-big data regime.
Yeah, if I may, so our tool, JotBio, specifically targets very small sample data sets and high dimensional data sets. And that's the typical case in molecular biology, very often in medicine. Just imagine you have a very expensive treatment of cancer or a rare cancer or some other disease, or you do some very difficult genetic manipulations in mice, and then you wait 3 years to kill them and do measurements. You may have 50 samples. That's it. All right. So this is a very common case in my world. And also, even in the industry, if you have you launch a new product or the competition launch a new product, so you want to use only fresh data, you may end up with small data samples. And another situation is when you have very rare classes. So you may have 10 million samples, but only 1 in a million is positive or something like that. That's also small data, right? And in all of these cases, forget about deep neural networks. It's going to be impossible to fit. I mean, you'll fit them, but you'll overfit them. Okay. So, and you need special techniques. You need really techniques to shield against overfitting and estimate performance well. And there's a whole other world with data like that, apart from industrial world with very big data. So they coexist.
Absolutely. It seems like the takeaway is that there is quite a lot of hype about large models these days, but still quite a lot of industries and science has very small data sets. So, and it's much less clear for some of these how to use large models. And so, yeah, there's still quite a lot of need for techniques on small data sets. Okay, so the next most popular question is about interpretability. So is lack of interpretability a major obstacle for practical usage of AutoML methods in industry? Anyone want to go ahead first?
Sure,
I can take that if you like. Okay, go ahead.
Sorry.
Sorry.
Yeah, I think it is interpretability is very important because, as I said, at least in my experience, we work with domain experts, medicine, biology, and the like, and unless they really understand what's going on, and unless it coincides with what they already believe from the literature, they're not going to use it. Okay, so. We have to invent ways to, first of all, interpret the models and also help them understand them. And it's also a big challenge trying to help people understand and interpret machine learning models that are not machine learning experts and they haven't done any data analysis in their lives, or they've only done basic math and then they went to medicine, for example. Interpretability is also an obstacle, but an extreme challenge, I think, because you shouldn't be only thinking about computer engineers and trying to explain to your colleagues in the industry. You should be thinking about, people from completely different domains, business executives, for example.
Yeah, go ahead, Bindu.
Okay, yeah. Hey, so I would say that this is the number one ask, right, of pretty much everyone to the point the other panelist was making, which is that, hey, we need explanations. And the way we've handled it at Abacus is we basically say, here are the state-of-the-art methods which are available to, for you, so you can actually try to interpret these predictions. And so even if you had, say, an AutoML algorithm which produced your model, we can use something called SHAP to actually help you you like figure out why your prediction is what it is. SHAP basically will tell you how much a particular feature contributes to a particular prediction. So it helps you kind of get your head around like why is this prediction what it is. There are a couple of other methods which are also available. I mean, there's something called explainable boosting machines, which can help a little bit. Trees are fundamentally interpretable, so that helps. And then finally, we've also like kind of automatically do these PDPs, these partial dependence plots, which also help. All of these are just kind of crutches in some way, though. They're not like perfect in telling you exactly why a prediction is what it is, especially with things like forecasting and stuff like that. But having said that, I think there's two parts to this. One is having these methods, having these, making sure that your predictions are explainable using some of these methods. The other part of it is educating the business folk that not everything is going to be extremely predictable, because like the human brain, your neural network is also going to like look at the patterns and make some predictions, and not everything has a reason behind it. And I think that combination has helped us to some extent to kind of like crack through the business stakeholders and get them to start adopting ML. So while 2 years ago it was like, look, we're not even going to use this because you'll have to explain every single prediction. Now we're seeing a lot more of like people kind of getting wrapping their head around this. Part of this is you can point to the LLMs and be like, hey, you're now beginning to accept LLMs. You should be able to accept some of these AutoML techniques. And I think that's, the industry is shifting that way.
Can I also add to that? I sort of think about it in like two different ways. Like in the first way, we have interpretability as sort of like a necessary prerequisite before we feel comfortable to deploy a machine learning algorithm, right, or a model. And it's sort of like the reason that it is useful is because what we're trying to do is build trust towards a particular prediction. I think that's the first way to think about it. But the second way to think about it is when the interpretability is itself the object, right? Like, and I wouldn't, for all I know, fully 50% of the reason people are using machine learning is not for the prediction, but is for the interpretation, right? So and this is a point that's been made on the podcast several times by various people who've been developing AutoML tools out in industry. And they say that, yeah, all of their, half their customers are interested just in understanding why a particular thing happened. Right, and they're not even interested in deploying it for future inferences.
So to kind of give my perspective on this, I think it's very interesting. I think that interpretability does have a place, certainly in the overall data scientist toolkit. Things like Shapley values, things like permutation shuffled feature importance are very fantastic black box techniques that do give insights about models. With that said, I think that people lean into models being more interpretable than they really are in a lot of cases. For example, with AutoGLON often will do something like multi-layer stack ensembling, which is basically extraordinarily, complicated modeling design. But really, XGBoost is no more interpretable than AutoGLON in this sense, because it already is a gradient boosting ensemble of all these different trees with these, feature subsets at each tree iteration, and you probably already did pre-processing on the data and all this other things, right? And so I think that interpretability is a pretty interesting topic in that regard when you also consider all the other necessities you need to do to even work with the data. And I think that looking deeper into how interpretability works with feature preprocessing and stuff like that would be pretty valuable. But also I see that a lot of the users, for example, of AutoGLON, don't necessarily care too much about interpretability, at least from what I've seen. I think that there's different groups, right? But there is definitely a huge community of people that just have a problem and they want to get the highest possible accuracy on it. And then they don't care about anything being interpretable because really they're trying to solve a business problem. And so it's kind of interesting, the different perspectives, right? But there's definitely a place for it, for sure.
Absolutely. Any other thoughts? Yeah. So yeah, I think just like last question, it seems like it really depends on the application. There's some applications where a company might just want to see accuracy get maxed out, and other applications, quite a lot, where where really interpretability is key, or maybe the only thing that matters. And yeah, where there's methods like SHAP, and but yeah, still it's a large part of mystery. Although also with the rise of LLMs, there's more and more companies that are just willing to accept ML without full interpretability. Okay, so the next question is, what are the biggest misconceptions that academia has about ML in industry and vice versa?
I can maybe give it a try. I think many things we've already talked about today. The one thing maybe to add, it's a bit contradicting what you just said, but also not always. But in some cases, I think academia is very often very much focusing on improving accuracy and coming up with new models that give you 1% better accuracy. But that I see in many projects and applications we have, like, this is not the main focus. So the main focus is often having a very simple solution that you can easily use.
I guess one follow-up question I have for that real quick is, what does it mean to be a simple solution?
Yeah, so that depends on the user and the problem, I would say. But from my experience, very often you have people that kind of have like two options. So either they just implement their own grid search in like 10 to 15 minutes and they're happy with that, or they could choose to like pick an automated machine learning solution, for example. And so if they kind of figure out, okay, it's complicated, I don't understand it, it probably would take me like a week or so to get it running, then I would consider that not a simple solution, and that's often then like a red flag for using these kind of tools. Yeah, that's what I see.
I mean, certainly if it takes a week to figure out how to use an AutoML system, someone did something wrong. It's an interesting perspective. I think in AutoML, at least, you know, with my team with AutoGluon, right, we focus very heavily on making it as easy as possible. Just pip install AutoGluon from AutoGluon.tabular, import tabular predictor.fit, right? And so it's kind of interesting, like the definitions of what is complex. I would say complexity comes from how hard is it to get it working, not necessarily how complex is the actual inner workings of it, because really it's a black box in most situations. People don't know the nuances of how XGBoost works. They still use it, right? So it's like, what's the difference between XGBoost and a linear regression and a multi-layer stack ensemble if it's still the same 3 lines of code no matter what?
I mean, this also depends on the kind of problem that you have and the user, so to say. So I often see like 2 types of problems. The first is that the users are not really machine learning or deep learning experts, but they just want to have like any solution and something working, and then that's kind of the scenario you are describing. But then we're also having problems where, especially in NAS domains, you have like deep learning experts and they already tuned their neural network like manually for quite some time and they want to use NAS like on top of that to like assist their workflow, so to say. And then they also really go deep and like they change things in the algorithm, they change up the search space and these kind of things, and then you need like a deep understanding of the method, but still you want to have a method that also works robustly with respect to these changes you make, and like you don't want to tune like the hyperparameters again of the AutoML tool after you've changed some component of the method.
So, if I may, I don't know. In my experience, like in academia, you choose your problem. That's the main thing. So I have an idea. This is the math I know. This is what I like. I have an idea about this, so I can apply it on the data that I want, under the conditions that I want, and so forth. When you're like in the industry, and either you're building a system or analyzing a data set, you know, you're data-driven, you're problem-driven. The client tells you what they need. You know, maybe you just studied machine learning with only IID data, and the client doesn't have IID data, right? Or something like that. So that means, you know, you don't need to invent new stuff, but you need to have like have a broad understanding of the field, different types of data, different types of techniques, and be able like to engineer like best practices solutions. I think that's a main idea. Now, when you're building like big systems and you don't do like analysis on a given data set, again, you're a little bit like not client-driven, but user-driven. So with JetBio, and I'm guessing with AutoGluon, you know, we see like what the users, the functionalities that the users want, and things like that, and then you prioritize that, and you try to find the solutions that are more important. You know, you don't just do the ones that are easy for you or academically, you know, more interesting. I think that's a major difference.
Yeah. Yeah, and let me chime in here. And I think, the first panelist said this around accuracy. Here is, I think, the fundamental issue. Again, from a very industry perspective, research is very kind of focused on benchmarks in a lot of cases, and we're constantly improving these benchmarks, right? I mean, usually you get your paper like accepted if you are the soda on something. And the issue with that is, and that like does lead to accuracy, but improvements, but accuracy improvements based on what the benchmark was. And because what the research benchmark is not necessarily reflective of real world problems, that's where we see divergence. So I would love to have a research team where I could just lift and shift, where we let's say invented something like, maybe in the LLM space, AutoML space, and then I could take that invention and apply that to the industry. And today, I don't believe that is easy or very possible to do. To some extent it is, but not completely possible. And I think the more we could get that to be more aligned, the more I think both sides benefit. And part of that could be like what we spoke about earlier on, which is kind of like rethinking our benchmarks to be more real world. And part of it could also be kind of like research basically saying, hey, this is a common problem which happens in the industry. Why don't I attack that? Versus just kind of being super focused on like SOTA, so to speak.
Yeah, let me also comment on this too. So I went back and I looked at all the different papers that were submitted to the conference now. And it's one of the things that I'm picking up is sort of like this assumption that if only we make AutoML more efficient, then ... right? Like that ... could like play out in different ways. Like, could we have more people adopt machine learning or AutoML if only it were more efficient? I am highly skeptical of that, right?
Yeah.
Like the main reason that people are not picking up AutoML today is not because of its inefficiency. Right? It's because, it's like because of many other challenges that are upstream, right? They might be cultural issues. They might not even understand that they have a machine learning problem in the first place. They might just really love to engineer stuff, and however much you want to like solve their problem, they don't want your solution because they want to feel smart, right? Or because they feel like they can't trust the solution. There's so many different ways, or because really the challenges are in the feature engineering, right? And they feel like that's 90% of their sweat anyway. Whatever, they'll put up with the rest of the 10%. So it feels to me like that's, if insofar as there's a misconception, it might be that if only we make it more efficient.
Great. So, yeah, great discussions on model complexity and efficiency, and what the differences between academia and industry. Okay, so maybe we can get through a couple more questions. So the next question is on open source. So do you use open source tools when they get released, or do you build your own implementation that fits your infra or code base?
Yes, just maybe we don't all answer all questions, so we go faster.
For sure, yeah.
And only
Sounds good. Sounds good. Yeah. And by the way, I think we can go about like 10 more minutes or so.
10 more minutes. Okay. Are these 6 things on the chat?
They're just. No, they're not questions.
They're not questions.
Just,
okay.
Yeah.
Okay.
Yeah, so I'd love to answer this one. So, so this one is about, I knew I wanted to answer it. What was it again?
Open source.
Open source, right. So AutoGluon currently depends, I believe if you do a pip freeze, it's about 170 packages. So we are standing on the shoulders of giants. And if scikit-learn didn't exist, right? If XGBoost didn't exist, if Hugging Face didn't exist, man, would our world be hell. Just saying. So I'm really appreciative of the open source community, and we want to reuse what they create as much as possible. I am not the expert on gradient boosting models. I'm not the expert on making a model zoo, right? There are people that literally dedicate their lives to making that thing as good as possible and documenting it and building a community around it. Hell yeah, I want to reuse that stuff. And I think that trying to build things yourself is going to lead you in a direction where you're going to become outdated and outpaced by the more general things that specialize in that you could have just built yourself on. So yeah, I would completely be in the realm of embracing open source with the comment that you shouldn't just incorporate every open source package that comes in. You need a clear vision and understanding of, does a certain open source package lead to you achieving what you're trying to achieve better? And then also you want to make sure that the overall complexity of what you're building doesn't explode too heavily, right? So try to modularize things, figure out how do you abstract away the concept of a model, and then figure out, okay, how do you make optional dependencies so that not everything needs to be installed, and therefore you can have minimal installations with just the things that is necessary for solving the particular problem.
So I have a question for you. You mainly commented on like well-established packages that you're working on top. How do you do this with like more like state-of-the-art methods, methods which are still like in a researchy mode? Like, would you also build them in, or like try to build them in, or in that case, would you rather do your own implementation from scratch, which kind of adheres to your like best practices and so on?
So it's on a case-by-case basis in this scenario. I mean, I think that scikit-learn does something similar with scikit-learn contrib, right? Where I think that they're quite hesitant to just adopt things that are recent and, you know, like just have the paper and like, I don't know, 12 GitHub stars. Right, and I'm of a similar vein. A lot of these types of projects, you know, it's a huge effort for an open source project to have continued and active development. And, you know, if there's a bug, you know, will they fix it in a timely manner? If there's a security issue, will they fix it? You know, and do they have a large enough community that their users are constantly pushing those people to improve the system? Right? You don't want to be shackled down by something. And so in some cases, for example, with packages like tabpfn, where again, we can modularize things and it's just a model, so it can be optional dependency, and therefore it only has an issue for people if they go seeking it, if like there's a problem with it. But otherwise, it's like low risk, right? Whereas, for example, us replacing pandas with some pandas alternative, that's like a whole nother ball game, right? You're kind of making a huge bet, and then if that thing doesn't keep up with pandas, you're going to be shooting yourself in the foot really hard.
Absolutely. Anybody else, or move to next question? All right, so the next question, one of the most upvoted questions, why is Ralph Herbrick not on the panel? He has a master's. Yeah, I was going to say, yeah, he would have been great to be on the panel, but he has a master's defense to attend. Yeah, should we all go around discussing that question? All right, so yeah, so the next most popular question, what are the current trends in AutoML that are exciting both in academia and industry?
Okay. I can take this one. I'm biased and probably you know my answer. So I think from the previous talk, automated causal discovery I think is important. Automating like AutoML for relational data, I think it's completely untapped. And maybe for time series, I mean large scale time series and things like that. That would be my guess.
By the way, also, I think this is also a good segue into any closing remarks any panelists want to say, because I think this will be the last question.
And that could have been my closing remarks too.
Perfect.
I guess we already said it, but like when you more in the direction of classical deep learning. It's, I guess, definitely foundation models. And so people in practice are moving away from this question, like, what's the best model for my use case, to which foundation model can I use for my use case, and how do I tune it? And yeah, as mentioned, this nicely fits the AutoML regime, and I guess it would be important that like the community already now starts on working in these kind of questions and evolves in this kind of direction, so that we can actually avoid that a gap appears in 1 or 2 years in this direction.
Yeah, I would second that LLMs are definitely something to keep an eye on regarding how it integrates into AutoML. Specifically, how can we use LLMs to make AutoML easier and more widely adopted, I think is a very interesting question. How can we use LLMs to solve the hard types of data preprocessing and preparation steps in order to then vend it into AutoML systems to get strong results? The kind of things that data scientists currently do that AutoML systems fail at. How do we do that, right? And I think that's a very interesting area.
Absolutely. And our other panelists?
Adam, do you want to go?
Yeah, sure. Yeah, I mean, to second that point, like LLMs, I think that without sounding too much like a broken record, I mean, like it's insofar as LLMs are able to help us parse user intention more clearly. I mean, I think that this is excellent. I see almost like an opportunity here and a bit of a threat too. I mean, like let me just say, like the threat is that I've seen company after company in the last few months just completely reprioritize everything that they do because it's absolutely important that they do something with LLMs. Why? It's not clear to them why they need to do this. I feel like it might be FOMO. Maybe their employees might leave for other places where they can play with that stuff. But at some point, every single person that I talk to in industry it's on their roadmap, and immediately it's just like the most urgent concern. When I organize events, I used to talk to a lot of people that call themselves machine learning engineers. And now the people that I talk to are mostly AI developers. And I really wonder about like that distinction all of a sudden, because people would ask me if I do machine learning, and I would say, yes, do you? And then they say, no, I only play with AI. That distinction between AI and ML, this I feel like is a new tension that might emerge. And I don't know the extent to which it's likely to just suck the wind out of ML, but it might, right? This is something I think to keep an eye out for. And so then there's another development happening sort of like on the data engineering track, which I've been keeping up with, which I think is also fascinating, which is the emergence of the semantic layer. And this is something that I've spoken about a little bit, but insofar as LLMs are able to provide that added context about the semantic meaning of data, right? Like what is that data? All of the work that is currently sort of like happening in the brains of the data scientists. If the LLMs can provide sufficient context to feed into an AutoML system, I feel like we could be ushering in a golden age of AutoML that is just able to ingest so much more about the actual operations of the business and then flourish in something pretty wonderful. So anyway, 2 thoughts.
Okay, so I can wrap with saying 3 different points. I think some of the panelists have made most of these points. The first one, I think, is foundation models. I do believe that a lot of like even tabular data could have some like hope with foundation models. We actually are working on a foundation model for time series. It's called Forecast PFN. We've released a paper on it on arXiv already, and I think submitted it to NeurIPS as well, actually. And the idea there is to see how we could get how you can basically predict into the future of a time series without having to train a whole new model, right? Using a foundation model for that. And I think we'll see a few more of that happening. The second is, actually my whole talk in another hour is going to be just this, generative AI meets AutoML, which is the idea of like using an LLM and mostly code generation actually. And we'll walk through some of that stuff on how to do data cleaning, data prep, and everything a data scientist does, and then feeding it into an AutoML system to basically get the whole thing automated end to end. So I do think LLMs do have a part there. Again, I do agree with the hype part. I mean, we are overhyping it, but it does a really good job of code generation, understanding data, also finding issues with data and so on. So I think there's a lot of hope as well. And then the third part of this is, I think AutoML techniques in general, sometimes get like kind of, it's just auto glue on versus like NAS versus whatever. I feel like, thinking about this a little bit higher level in terms of like saying feature selection, including those kinds of like concepts into the umbrella of AutoML, I think it is very exciting because a lot of times, feature selection tends to be important, but people don't consider that AutoML, which if we could, it gets to be a much better, much more robust system.
All right, great, thank you. Yeah, definitely looks like a very exciting space in both academia and industry. And so, yeah, thank you all panelists once again. Thanks also for staying a little bit later. And yeah, thanks.